Okay, so this is an example for virtual work of a force and a moment. Okay, so we have a disk, and so the information that we have the weight of the disk. We have the weight of the disk in the middle. So let's do the flip diagram on the left. The weight is equal to 10 pounds. Know that the force, before that is applied P, it's equal to 8 pounds. The moment, we have a moment that is applied in the middle of 8 pound times feet. The spring is originally unstretched, and the spring, after we rotate, the spring is stretched, so we have the force of the spring going down because the spring is stretched. And now for the displacement. So what we have is an angle delta theta. Okay, it's huge, but in real it's small. Okay, so it's delta theta. And the question is, how much is delta theta when we apply the force P? So before we apply the force P and the moment, the spring is unstretched, and after we apply the moment and the force P, the spring is stretched. Okay, so let me grab my. So we have du. So the principle of work and energy. We have the delta U of the force of the spring plus the delta U of the weight plus the delta U of the moment plus the delta U of the force P. It's equal to 0. Okay. So the weight is applied in the middle. Okay. So there's no displacement in the middle. So the work of the force for W, it's equal to 0. For the force of the spring, so it's equal to the force of the spring. I like my big pen. The force of the spring time the length, the delta S. Okay, so the delta S. And the delta S is equal to what? It's equal to R, so the 1.5 times the delta theta. Okay, so this is the delta theta, this is R, and this is the delta S. Plus delta M, I forget the U on both of them. Delta U M and delta U P. Okay, so for the delta UM, it's equal to what? The moment times the delta theta. That's the easiest one. And the delta P, it's equal to delta UP, it's equal to P time the displacement, same thing, the displacement delta S, that is equal to R delta theta. So P time 1.5 times delta theta, it's equal to 0. Okay, so we have the force of the spring plus the moment, it's equal to 8 delta theta, plus the force P, it's equal also to 8 times 1.5, the radius, times delta theta, it's equal to 0. Okay, we are already almost there. The force of the spring, try to make it a bit smaller, not too small. So the force of the spring, okay, because this is the force of spring. For the spring, it's equal to what? It's equal to K times the delta S. And time the 1.5 delta theta. Okay, this is 8 plus 8 times 1.5. So let me find this 8. Oops, plus 8 times 1.5. Maybe you already get it. So it's 20 delta theta to the right. K is equal to 12. Oh, and there's one thing that I need to include. Which directions is the work of the force of the spring? It's a minus because the force of the spring is in the opposite direction of the delta theta. Okay, so minus K it's equal to 12, so minus 12. Delta S it's equal to 1.5 delta theta again, and time 1.5 delta theta, okay, plus 20 delta theta. It's equal to 0. So we have 12 times 1.5 times 1.5. So this is equal to minus 27 delta theta square plus 20 delta theta. So To solve this one, we can factorize by delta theta. So we have delta theta that is equal to delta theta time minus 27 delta theta plus 20. It's equal to 0. So there's two solutions. Either delta theta equals 0, and when delta theta is 0 equals 0, but it's not equal to 0, or either minus 27 delta theta plus 20, it's equal to 0. So we find that delta theta is equal to minus 20 divided by 27. That's a radian. So this one is 20 divided by 27, so 0.740. And in degrees, it gives us divided by 42 degrees. Let me check this answer. Oh, I don't have the answer there. Oh, okay, that's okay. So I find delta theta is equal to 42.4 degrees. So it's more than a little delta theta. It's a little bit more displacements, but that's a way to find the equilibrium. Okay, so after 45, almost 45 degrees, 42 degrees, your wheel will be at equilibrium between the force of the spring, the moment, and the force P. So that's it for this example, and you are good to take your quiz, but let me explain another one in another video, just for your information if you want. Bye-bye.